In this video, I'm going to teach you lesson 6.3, which is exponential functions. And to start off, we're going to talk about a specific situation and see if you can figure out what the best option would be. So in this situation, if a random stranger walks up to you on the street and asks you, would you rather be given $50 a day, or would you rather get a penny on the first day and then 2 pennies on the second day and 4 pennies on the next day and so on? So basically the amount of pennies doubles each day. So what I'm going to have you do first is to try to figure out what you think the better deal would be. So would it be better to take $50 a day, or would it be better to do the doubling strategy? So go ahead and pause the video here, see if you can figure out how much money you'll have on each of these days, and then it will help us see which one will be best. So if we pick option one is $50 a day. So how could we write option 1 as an equation? So on day 1 for this option, you're going to have $50, and then day 2 would be 100, and then day 3, 150, basically going up by 50. So if we want to try to write this as an equation, we can represent it using a linear equation, very similar to what we talked about in chapter 5. So if I want to try to create the slope for this, what is my rate of change? My rate of change here is 50 for each day. So basically it's going up by 50 every single day. Our y-intercept would be 0 because they haven't given you any money yet on day 0. Basically, you haven't run into the situation. So the equation would be y equals 50x. So we can represent it using something we already know. But then if we did option 2, we kind of run into a problem. So first of all, day 1, you'll have 1 penny. Day 2, 2 pennies. Day 3, 4 pennies. Basically goes up from there, doubling each time. And if I try to go through and figure out how these are changing, it's a different number every single time. So I added 1 cent, I added 2 cents, I added 4 cents. There's no slope for this. So I can't really create a linear equation. So I'm going to have to learn about something else in order to represent this situation. So hopefully you picked option 2, because that will end up giving you way more money as the days go on than doing the $50 a day. But either one's a great situation. Free money's free money. So lesson 6.3, we're going to look at what's the difference between linear and exponential, so 2 different function forms. We're going to talk about how you can identify each one using a table. We'll talk about evaluating, and then we're also going to end with graphing and then features. So first thing I'm going to have you start with is to put some vocabulary in your student journal. So we're going to be on page 180. The only word that we have is an exponential function. And what this is it's a non-linear function, so it can't be represented with a line, that can be written as y equals a times b to the x. And make sure you write that x small because that's an exponent for the equation. And then I'm going to have you label what all the letters mean to kind of help you as we go on through the chapter. So first of all, a is our y-intercept. So it's where it's starting on the y-axis. The b is the growth or decay factor. So it tells us basically how the numbers are changing as we keep changing our values. And then x is our time. So now one other thing I'm going to have you put on the bottom of 180 is just some notes to help you look at the differences between the two. That's a big part of what we're going to do in this section. So first of all, a linear function can be written as y equals mx plus b. So a regular line like what we talked about in chapter 5 and then before that. And then on a table, what you're going to look for is the y values are changing by plus or by minus. And then for an exponential function, it's y equals a times b to the x. And then on a table, the y values are changing by multiplying or dividing. So just to kind of give you a couple little facts with that. All right, let's go ahead and look at some examples of these. So this is going to be on 181. We're going to try to determine whether the table represents a linear or an exponential function and then explain it. So first thing we're going to do when we do this is double check that your x values are changing by a constant number. So if I look on here, all of these are going up by 1, so that's good. And then what you might want to put on here is linear is either plus or minus, and then exponential is multiply or divide. So first thing I usually do when I look at these examples is to see if the y values are increasing or decreasing as we keep moving. So if I look through this, I've got 8, 4, 2, 1. So that means the numbers are decreasing. So I know it's either has to be subtraction or division when I'm looking at this. So if I look through and I try to do subtraction and I go from 8 to 4, I have to think about what did I subtract by? So 8 minus what gives me 4? So 8 minus 4 gives me 4. And then 4 minus something equals 2, but that's not 4, so it can't be subtraction. So then what I'm going to try is see if I can do division. So if I think about 8 divided by what gives me 4, and in this case it's divides by 2. And if I take 4 and then divide it by 2, I get 2. And then if I take 2 and divide it by 2, I get 1. So basically these are changing by dividing by 2. And then if my values are dividing by 2, that means that this is going to be an exponential function. So I'm going to label as exponential, and then I can put the y values are divided by 2. And in the later sections, we'll learn more precise vocab of what we're looking for. For now, it's just kind of seeing what the y values are doing. All right, let's go ahead and try number 2. So number 2, I've got same x values going up by 1, so that's good. And then my y values, if I look at them, they're increasing, they're getting bigger. So 3 to 7, 11, and then 15. So this would either have to be addition or multiplication if the numbers are going up. So if I start with addition, I have to think about 3 plus what gives me 7. So 3 plus 4 gives me 7. 7 plus 4 gives me 11. And then 11 plus 4 gives me 15. So these are going up by addition. So basically with these, you're kind of guessing and checking to see how the values are changing. So this is plus 4, plus 4, plus 4. So if these are changing by adding 4, then this is going to be a linear representation. And the reason why is the y values are increasing by 4 or adding by 4, whatever you want to put. Plus 4. All right, take a second, pause it here, try 3 and 4, see if you can figure these out. They're a little trickier, but then we'll talk about them together. All right, so number 3, check your x values. So it's still going up by 1, so that's good. And then my y values are decreasing. So that means it's either subtraction or division. So on here, what I'd start with is subtraction, see if I can figure out if that's how it's changing. So 12 minus what gives me 9? So 12 minus 3 gives me 9. 9 minus 3 gives me 6. And 6 minus 3 gives me 3. So this one is linear. And then the y values are decreasing by, and then you could put 4 or you're subtracting 4 or however you want to write it. Okay, they're going down by 4. And then number 4 is kind of tricky. If I start with the first couple, these are decimals, so it's a little harder to see. So I kind of suggest move down a little bit, see if you can go down from this spot. So these values are definitely increasing. So it's either addition or multiplication. And when I look at this, if I start with 0.5 to 2, if I added to get there, it would be 1.5. And then if I take 2 plus 1.5, it's not 8. So it's not addition. But if I want to try multiplication, 0.5 times what gives me 2? 0.5 times 4 gives me 2. And then 2 times 4 gives me 8. So this one, and then you're just going to have to double check up here, make sure this works, and it does. So multiplying by 4 is how these are changing. So then this would be exponential because it's multiplication. And then you could put y values are multiplied by 4. So basically, you're just explaining why you're picking what you picked. And then that's for the table. And then what we're going to do next is we're going to talk about evaluating. So what we did from this table is we were basically given the x value and given the y value. But sometimes you're given the equation and then you need to find what the y value is. And all evaluating is just using your calculator to help you find what value you're looking for. So first one that we have, number 5, is y equals 3 to the x, and then it says x equals 5. So what you're going to do is you're going to substitute or take 5 and plug it in for this x value. So what you're going to have to type in into your calculator is 3. And then if I want an exponent, I have to use a button called the caret button. So it looks like this little tent. This will help me get that exponent spot. And then it says 5. So we're going to plug in 5. And then this is what we need to actually calculate. So you can take your calculator and then you're going to type in. So you're going to type in 3 and then hit the caret button and then put in 5 and hit enter. And then this will give you the value that you're looking for. So 243. And then that's your answer. And then next thing we've got is y equals 1/4 to the x. And then we want to find it for 3. So that means we're going to take y equals and then type in 1 divided by 4 and then caret 3 because that's the value that they gave us. So then now what you're going to have to do is you're going to plug this in again. And then on this one, you could actually use the ABC button if you wanted a fraction answer. But typically you want decimals with these. So you're going to type in parenthesis 1 divided by 4 and then caret button and then 3. And then this will give us our value that we're looking for. So this is it as a decimal. You could also use that ABC button to help you get the fraction. It just kind of depends what you're looking for. So this is your answer. All right, go ahead, try number 7. So you can pause it right here and then I'll go through it with you. Okay, number 7, we're taking this equation. So 3 parenthesis, and the parentheses are right above that 8 and 9 on your calculator. 4, and then caret 4. And you have to make sure you put the parentheses on there so that way you don't get 34 to the 4th. You want to have 4 to the 4th. So we're going to type that in. So 3 parenthesis 4, and then raise it to the 4th power. And then you should have gotten 768. So this is what evaluating looks like. And the reason that we need evaluating is so that way we can make graphs of what we're looking for our exponential. So then now, let's double check. So we did 1, 2, 3, 4. We did those. Yep, make sure you type these in your calculator practice because when you take the quiz, I can't tell you how to do these anymore. So you have to make sure you do it with me. All right. Okay, so now how can we graph exponentials? So if you look at page 180, so flip back, these are what the graphs of our exponentials look like. What I want you to do on your piece of paper is go ahead and highlight the top line that's on both of these. This is what we normally look at is when our A values are above 0. Okay, so go ahead and highlight those. We're going to talk a little bit more about how you tell the difference between the graphs themselves in the next lesson, but we're going to learn how to create these in just a bit. All right, so let's go ahead and try this out. First thing I'm going to have you do is you're going to change the number 8 so that way it's a positive 2x. So go ahead and do that on your paper. And then we are going to graph the function and then describe the domain and range. You're also going to need to draw those lines down the middle so that way we can graph these as well. Okay, so we're going to go ahead and draw those. And then we will graph these. Let me graph those on there. All right. So here's our graph. So make sure it says 2 to the x, positive. First thing we're going to start with is creating our table. So for our table, what will work for some good numbers for you would be -2, -1, 0, 1, and 2. These are very similar to the ones we used first semester for graphing, just so you can get a good idea of what the graph looks like on both sides. So if we want to do this, creating the table is just doing exactly like what we did up here, but you do it 5 times. So we're going to use these 5 numbers and plug them into our equation so we can find those values. So first one, if we want to plug in -2, we're going to take our equation, so y equals 2 to the x, and we're going to type in 2 to the -2. And for these, you're going to want to use a decimal because we're going to have to graph them. So we need to know where they're located. So 2 caret -2, and then we'll get 0.25. And you can show this work right here every time, but if you're getting where it's coming from, You don't have to show it from here, but I'd put it at least once because remember, this is a good reference for your notes when you do those. All right, then we're going to do 2 to the negative 1. So we can find that value. 2 to the negative 1 is 0.5. 2 to the 0 is actually one of our exponent rules. Anything to the 0 is 1. And then we've got 2 to the first, which is 2. And then 2 squared, so 2 to the 2 is 4. And then now what we're going to do is we're going to take each of those values and they become our coordinate points. So we're going to graph the point negative 2, 0.25, and then graph negative 1, 0.5, 0, 1, basically all these values, 1, 2, and 2, 4. And then remember when you're graphing points, you're going to be using your x, y. X is moving it left or right. If it's moving to the left, it's negative. If it's moving to the right, it's positive. And then y values is going up or down, so positive or negative. So let's go ahead and graph these. So negative 2.25 would be going left 2 and then going just a little bit above the x-axis. And there's my point. And then negative 1.5 would be going left 1 and then up 0.5. There's no way to really make this perfect. You just want to get it pretty close. 0, 1 is our y-intercept. So that's located right here. 1, 2 would be going right 1, up 2, and then 2, 4. So right 2, up 1, 2, 3, 4. And then we're going to go ahead and connect our line, but there's one thing we have to be careful of. So with exponentials, there's always going to be something that's called an asymptote. Okay, so it's kind of weird, kind of sounds funny. But what that is, it's the line that the graph gets really, really close to, but it doesn't cross. In this case, it's going through the x-axis. So there's basically like a little line here that it doesn't let it go over. Basically, there's some values that won't work for our equation, and that's where they're going to be located. So when we connect this, we're going to draw arrows on both ends, but we can't cross the x-axis. So you're going to have to draw it really, really, really close, but it's never going to touch it, never go across it. All right, and then we want to find the domain and the range. Okay, so the domain is what x values that this covers. So if I look at my equation, I look at my arrows, basically I'm looking at my graph and I want to see, does it go all the way to the left and the right? Does it cover every x value I have? And this one doesn't have any holes or anything like super weird on it. So the domain is going to be all real numbers. It covers every single x value. And then for your range, we're going to look at what y values it covers. So the range is a little trickier though. If I look at my graph, we said, hey, it doesn't cross this line right here because of the asymptote. So my range or my y values is only going to be the values that are above that section. So it doesn't include any of my negatives. So to show the numbers that are above it, we're going to use an inequality. So y and then 0. And if we want to represent all of the values that are above 0, we're going to use greater than. And we can't do equal to because of that asymptote that's going through the x-axis. All right, let's go ahead and try number 9. So number 9, same deal. We're going to make a table. We're going to find the domain and the range, and we're going to graph it. So start off with our table. So x, y. We've got negative 2, negative 1, 0, 1, 2. And then we're going to plug it into the equation that's up there. Remember, don't use the ABC button so you can get some decimals. But we're going to take this equation and we're going to plug in negative 2 to start. So y equals 2 parenthesis 1 divided by 4. And then hit the caret button. And then we're going to put our negative 2 in there. Okay, so if I plug that in, 2 parenthesis 1 divided by 4, and then raise it to the negative 2, we're going to get 32, which is like, oh no, it's not going to fit on our graph. And you can actually change the scale if you need to fit more points. But I am totally fine with graphing the rest of them and then seeing what our shape looks like. Okay, so here's, but also make those lines on there because we're going to have to graph it. But we're going to go ahead now and plug in negative 1. So instead of our x value, we're going to plug in negative 1, and we end up with 8. And then if I plug in 0, the whole thing doesn't turn into 1, just that little section. So we're going to do 2 parenthesis 1 divided by 4, and then raise it to the 0 power. And that gives me 2. And then same deal, but we're going to use 1. So that's 0.5. And then we're going to use 2. So 0.125. And then now we're going to graph all of our points. So we're going to use these values. So this is going to be -2, 32, -1, 8, 0, 2, 1.5, and then 2, 0.125. We're going to graph all those. So like we were talking about earlier, you can't really fit -2, 32, but as long as you've got enough points to get the shape, then you're okay. So we're going to start with -1, 8. So if I go to -1, 8, we're going to go left 1 and then go up 1, 2, 3, 4, 5, 6, 7, 8. Here's our first point. And then 0, 2. So go to the middle and then go up 2. And remember, you can write this on your paper if you need that to help you with graphing the points still. That would be a really good reference to help you when you do your quiz. 1.5. And then 2, really, really, really close, but don't cross that x-axis because of the x or the asymptote. Then we're going to connect our dots. Don't cross it, don't cross it, don't cross it. Gets really, really close and then keeps going. So it looks like this. And then last thing we have to do is the domain and the range. So the domain is what x values it covers. And in this case, it covers all real numbers. That one's a give ya because it's not going to change. The range could change if we move it up or down. But on here, we still don't have the negatives and we still don't have the lines that are on the x-axis. So we're going to have our range is y values that are greater than 0. So that is exponential. So you have to look at a table and help look at how the y values are changing. You have to evaluate, so type things into your calculator. And then the last part is graphing, and the graphing we'll continue to work on with the next lesson as well.